Welcome to this course, Java, the intermediate level. This course is a presentation of coding boot camps. We will be covering intermediate level Java concepts, Java syntax, maybe some advanced. Therefore, as a prerequisite, it's strongly recommended that you take the Introduction to Java Programming course. This course is offered by Coding Boot Camps. Our first session, session 1, is going to be fundamental searching and sorting. We'll look at the algorithms and we will look at the Java code and the Java solutions for fundamental searching and fundamental sorting. In this video, we'll briefly discuss the introduction to searching algorithms, and we will look at the Java solution for the linear search and the binary search. The algorithm for the linear search or for the sequential search involves a method for building a data structure with a list of values and then iterating through that list of values one at a time until that desired value is found. So therefore, we create the data structure and add the values to all of the indexes for that data structure. It can be a long list of items, and then the search value is entered, and with this algorithm we iterate through each of the values and check to see if we've discovered or if we found the value for which we are searching. The worst case performance for this type of algorithm is that we have to iterate through the entire collection and the value that we're looking for is the last one, or that we loop through the entire collection and find that there were no values found. The speed of the search grows linear with the number of items within the collection. So the bigger the list, the bigger the data structure, the longer the search may take. Here is the linear searching algorithm coded. As you can see here, we can see the header here. We pass in an array and we have pass in 2 integers, and now we are looping through the array using the loop, and here we are returning the index of the element if the element is found. So, and then we return a -1 if the element is not found. So the algorithm is relatively simple, and just like you may have suspected, we do use a straightforward for loop and loop through the entire array, searching for the value that we passed in and determining if indeed we have found an equivalent to that value, and then returning the index in the array where that value is. Notice we're returning the index. The binary search algorithm uses a little more of a more complex approach. So with a binary search, it searches a sorted array by repeatedly dividing the search interval in half. So it begins with an interval covering the entire data structure. If the value of the search key is less than the item in the middle of the interval, it narrows the interval to the lower half. Otherwise, it narrows it to the upper half, repeatedly checking until the value is found or the interval is empty. So this algorithm is faster. However, when it comes time to code it, it's going to be more complex. With binary search, the algorithm is based on the array being sorted. So we can see here the array is sorted. So if we're looking for 23 in the 10 element array, it's going to start and take half, and then it is going to, since 23 is bigger than 16, It will know what half to search in, and when 23 is found, if the value is found, it'll return the index of the array where the value is, and this is 5 because don't forget it's 0 base, so this is the 0th member, which is 2, 0, 1, 2, 3, 4, 5. So then the fifth index will be returned, and then it can quickly be determined that that value is 23. And that 23 is indeed in the index number 5. This is an example of the big O of n, or big O of log of n, where that is the processing time of an algorithm, not of an actual function, software function, because that can be dependent upon hardware and other items. The big O of n strictly looks at how many steps and what has to be done in order for the algorithm to complete. This is a great exercise to try for the binary search. So we see this class binary search, and we see that it also has the main method. So we have here our class, which binary search, which we will instantiate here as OB. And we can see here that as we call it, we'll be passing in the array, and we have the array length, and we are searching for 10, and we are going to return the result here, so the index of the result. So if the result is not -1, which means that 10 wasn't found, we will return the index of where 10 is in the array. So if we take a look at the array here, we pass in the array, and we see the array right here. We have our length, which we have, and we have our x, and we have our r. So we pass that in, and if r is greater than 1, we can see here it searches for the mid, and then it will go through search the array depending on where it falls in that array, and then it will return here our binary search results. So here we can see if the element is smaller than mid, then it can only be present in the left subarray. Else the element can only be present in the right subarray. So we are using the subarray approach, and if we don't find it at all, we return -1. So in this case, we were looking for 10. 10 is indeed in the array, and it is in the 0, 1, 2, 3rd position. So the 3 would be returned. So key this in, enter this in to your Eclipse or IntelliJ or some other integrated development environment, or you can just use Notepad, and you can try this for yourself.